Okay, now let's look at question A5. Write a Java method which takes a cell representing a linked list and returns an array of the length of a linked list containing the elements of a linked list in the order they occur in the list. Okay, now this is maybe a tricky problem. It's not a problem that is in the notes. You need to work out for yourself how to do it. Okay, now when writing code, as I said, what you need to do, first thing, what does it take as an argument and what does it return? It doesn't say it's a static method, but it doesn't say it's called an object, so it is a static method. Takes a set object, returns an array of a length of a list, contains the elements. Okay, so let's call it make array. And it takes an object of type cell T. What else do we need? It needs a return type. It's a return type array of T. Now, T is a type variable. This is a generic method, so it needs a declaration of type variable T. And as I said, this is not being called on an object, so although the question didn't say it was a static, it is actually a static method. Okay, now let's try and think again in terms of diagrams what we're doing here. Okay, so here's our linked list, 10, 20, 30, 40. And we want to result in an array. That's what we return. Okay, so looking at it diagrammatically helps us think of the concept of what we're doing here. We've got this, we want that. Now, the first problem is that an array must be created of the size we need. When we start off with this list, we don't know its length. We don't know what size array to make, so we're going to have to find the length of a linked list. Okay, so here we've got a standard start a pointer at the list and move it down, increase the count by 1. This will give us the size of a linked list. From that we know the length of the array. There's this little problem here. I'm going to cover that later. We need an array of T of size count. This will create us, in this case, a blank array of size 4. That's what we want. Now, little tricky bit in this question, you wouldn't lose many marks for not getting this right. If you want it perfect, remember we said that actually you can't directly create an array using a type variable. What you actually need to do is use casting. Easily forgotten that one. Well, okay, from now on it's easy. Again, we loop through, but this time filling the cells of the array, because we now know the size, with the first elements of each cell in the linked list. So we need an index. Again, a standard loop through a linked list. And actually the update is going to be doing two things: just move the pointer on and increase the count by 1, I++, the index by 1. So that's it. So the pointer will start off here and put 10 in here. I is increasing, pointers move down. So go down the list, we fill in this array, got the array filled in, and then we return it. And we've solved the problem. This return is not inside this for loop, it's outside the for loop, it's at the end of the whole loop. I mean the closing brackets to close it off. And there's your answer to that problem. Okay, so involved in a little bit of thinking, but it's very standard list processing. Haven't seen quite this problem before, but if you're a confident coder, you can happy with arrays and linked lists, you should be able to code this up. And as ever, marks for these coding questions, you'll get partial marks if it's partially right. So if this wasn't quite correct, but you weren't making the correct header and some sort of use of loops and pointers, you could get correct header 1 mark, showing that at least you understand the general idea of the looping through a loop, 2 marks, maybe some odd bits wrong, 3 marks, 4 marks for almost correct, maybe for getting something like this little issue here with the objects of a type variable, 5 marks for getting it completely correct. That's how a marking scheme for this question would work. Well, I've looked at this answer and I'm completely happy with one minor thing. I missed the closing final closing curly bracket. Well, I wouldn't deduct a mark for something like that. Okay, so I'm happy with this answer, it's correct. The funny thing is, I thought this was the most challenging of the questions. It's asking you to do something which is just a little bit different from what we've done in class. You hadn't actually seen anything quite like this. And I've even got the tricky bit right to remember that you can't directly create an array using a type there, which you've got to create an object and then cast it to type. So this is all correct on that one tricky point. Now think about this. What I think I've probably got this correct because I thought this is the most challenging question and I thought carefully about my answer and got it correct. The earlier ones I thought, oh, this is stuff I know very well, I teach this every year, I know what it is. I actually didn't think carefully when I looked at the question, I went through it, and you see particularly on question 2, a little bit on question 3, 4, I made some silly mistakes, but I was too confident. So it shows I know my stuff, but if I don't think carefully about what I'm doing, I make mistakes. Look at the question, think carefully about what it does before writing it down. Don't rush it, even if you think you know the answer, because that's when you're likely to make mistakes. Difficult question, I got it right because I thought carefully about it. Doesn't mean I shouldn't go back and review it. Go back and review to make sure you've got it correct. Think about it if you've got time. Is this what's correct? It's all the way to pick up those crucial extra marks. The crucial extra marks where you're correcting silly mistakes are going to be the ones that pick up your mark from a B to a grade A. We all want grade A's, don't we? So if we're BCs and we're capable of grade A's, just give it an extra little bit of review if you've got time at the end to put up with silly mistakes which get you those crucial extra points. You can do it.